machen.
Würde schon machen. Okay, yeah. Recording's on. Awesome.
Perfect. Pause, stop. Nice.
Nice, yeah. All right, let's start. Thanks for joining. So today, Ansgar is going to review my code, and we're going to talk about code generation. So the project I've been working on the last few days feels like a week or something, but was actually 3 weeks. Is code generation. So the idea is to get us some HCL, like some existing Terraform configuration, and we get you your working CDK project out of that, so you can hit the ground fast. That's the base idea.
Mm-hmm.
Let me walk you through it, and you pause me every time you see something that's strange or
yeah,
interesting.
I haven't had to look at anything yet, so
that's great. Yeah, so let's start from the actual user side. So in our CLI package, we now have the convert command. That one is the this way. Great. That's one is the first thing that I implemented and the fundamental thing. So as you can see in the examples here, the idea is you get a file from standard in, and you convert that, and then on standard out you get yeah, some working Terraform configuration. So yeah, you actually have to do funny. Oh wait, you actually have to do some funny check for TTY thing if you want to read a string here. I was surprised that it wasn't simpler in Node. Mm-hmm. But yeah, in the end we get the input and we put it into this convert command, and if you specify a file, we write that for you, and otherwise we just console log it to standard out. Mm-hmm. And the convert command is part of a new package that we're going to publish. It's HCL to CDK. And the idea is that we can, by publishing this package, we can allow others to build upon this functionality and create new products, new ideas of that. For example, a thing we tentatively planned for the future is to have some integration to the Terraform plugin for VS Code, that you can just copy something from the registry, for example, like some HCL example, and you paste in the working CDK definitions. That's the idea. So as far as the package. Oh,
yeah. I have a question for this CLI still.
Yeah, cool.
So for the first version, it's just taking from standard in and not reading any file or directory on its own.
Yeah,
I got that right.
Yeah, from standard in.
Okay.
It's also like the base idea. I wouldn't want to change it to read from some file, because you can just use cut.
Yeah,
of that.
That's perfectly fine. My question is just if there's the alias file, I would have thought like, oh, that's I could also specify my input file, and does it accidentally overwrite the output? So if I specify my main,
I mean, not accidentally.
There, would it override it?
Yeah, it would purposely override it. That's a great thing. I'll add a to-do comment here that we name the file thing a bit different.
Yeah, maybe that might help. And maybe if it already exists, some warning or something, but
yeah, no warnings. It's just if the file is there, we print it. Yeah, cool. Thank you.
So if file, if it's supplied, yeah, okay.
Yeah, if it's supplied, we just write it.
Yeah. All right. Yeah.
Super simple.
Yeah.
To be fair, the file thing is more of a convenience thing anyway. We could also think about dropping that to make it less ambiguous.
Okay. Yeah, I was just wondering.
Yeah. Yeah, cool. Let's take a look at the convert function that we call. So basically, under the hood, we have a transformation that converts the HCL to TypeScript. And if you specify a different language than TypeScript, we have Rosetta in place, which is provided by JSII, so by the AWS folks. And we have this simple method here that converts these to like Python, Java, or C#, the TypeScript code you supply. So by getting everything to TypeScript, we can offboard all the other logic to Rosetta and only have to implement like proper TypeScript generation, which is quite nice. Not so much to maintain. We go over that a bit later. Let's first dive into the converted TypeScript function. That's like the centerpiece of the entire PR and yeah, the main work.
Yeah.
So yeah, it gets a file name in an HCL string. I think the file name is not really needed. We could remove that later on, but this also doesn't harm too much.
What is it used for?
The pass command uses it. Jumping doesn't work between these packages. So we have this other package, HCL to JSON.
Yeah.
That's what we use here to parse. And HCL to JSON actually is a WebAssembly library. So we have this this main Go, like it's generated from Go, and we have this parse function here that uses this convert function, and this is for like HCL to JSON. So it's a Go converter we use here, and that for whatever reason needs a file name. I don't think it's it changes something on the output, but I'm not quite sure.
Yeah, that would be my question, what that file name is used for, if it's accidentally overwritten as well, or just some temp file, or what?
I haven't seen it anywhere, so I assume it's just not used.
Okay, and what do you pass in for the file name? It was something with blah blah.hcl, some standard in.hcl, right?
Yeah, exactly. It's just a placeholder. Or in the other case, I use like convert.hcl or something and test, so it doesn't really have any effect on the output.
Okay.
So probably would be wise to drop it. I had to do. It's something I added at the beginning and kind of forgot to worry about again.
Yeah.
Funny. Cool. So yeah, we pass the JSON, and then we have we pass this into the schema. We define a schema using Zord, just because I want to make sure that we have some structure in place and some type safety at least. So lots of the Terraform configuration is loosely typed, or not loosely typed, but it's really unstructured, and it's a bit nicer to have a bit of type safety where we can.
Where do you jump into this again, where you do the validation? Could you show me that again?
Oh, yeah, here, sure.
Oh, the parsing.
So we get the JSON, we do schema parse, and get the plan of it. So the JSON representation of the HCL.
Oh, so that is the stringified JSON kind, and you do like JSON parse, but you do it with a schema to catch errors?
This JSON here is not stringified. That's the real record of to any. And this here is the proper.
So it's just
the one with proper types. Yeah, it's just type checking and checking if, like, it would throw an error if there's like an unknown key or something, or some weird stuff that we don't know. So we are a bit explicit about. For example,
so it's also erroring whenever there's something unexpected. So
yeah, exactly.
Like within,
if we have like a new version of Terraform that now does some, or like the converter that now does something different than the previous one, would get an error, and we would get an early warning that things are not working anymore. And we wouldn't get like a strange error somewhere in between the generation. That's hard to find out what it's about.
Yeah, I suspect the error messages might read read kind of cryptic currently if they surface. If there's a ZOT error, maybe there's a way to kind of catch it. And if it's such an error, we could also add a line before that error or before printing it, like about like, okay, this was unexpected, maybe using your Terraform or something.
I actually do for that as well.
Yeah, in the end, it's very easy for me to just add to-dos because there's always things to improve. You could also add in.
Yeah, sure, but that's an easy one. It should be like one try catch and should be done with that.
Catch ZOT errors and
Because you're right. I mean, for us, it's easy to know then, okay, it's ZOT error, so schema, but if someone is not familiar with the code base, it's definitely harder. Definitely good point.
Very hard, yeah. Okay, and how does it go on? Then you're doing some.
So after that, the base problem that, like the biggest problem we had to solve here is if you get the JSON and if you get HCL, both are static representations, basically. So there's no concept of order in them. So you could define like a resource in HCL, and then after that resource is defined, you can define another one that is being relied on by the first one. So you could have inverse orders in your HCL, and that's totally fine, and that's sort of a feature of HCL. But for programming languages, you need to have an order. So that's what we're after here.
What's in the comment in line 35 has different representation based on if?
Let me add word wrap.
It's reference. Okay.
Yeah. So let me show you what that means. If we look at what's a good one, like resources is a good one, I think. It's a bit more complex. So here we are on the generation. That's like the file only with the code generation. And wait a second. No, that's the wrong thing I showed you now.
It looked complicated.
Yeah, we get to that a bit later. Let's take a look at the iterators. That's what I meant. So we have few iterators here for the different types of things. So providers have a different format than like global things. So global would be things that are not namespaced. So if you have like resources or data, these are namespaced by provider and then the name of the resource and these others, variables and outputs, they are not namespaced. So that's why we have different iterators, but in the end, all they all do here is they return an ID. So for example, in this case, it's for namespace. So here would be either data.docker.docker image, or if it's a resource and no prefix is defined, then it would be like docker.docker image. So we have an identifier that is the also the identifier that's used if you write HCL and target something. So if I would write like HCL and reference something, I would do like I don't know, docker image dot nginx dot version or something, and use that somewhere. So this ID is saved as the key of the object, and the value is a function that gets a directed graph, which is our dependency graph that we are going to construct now. And the method we put in, the function we put in, makes use of the graph. And for example, you can see in the generation I just showed, no, I moved here. Let's go to the resource. So you see the graph is used here, mainly to get a reference and see if the ID that this thing has is used somewhere in the graph. And if that's the case, we are going to, like, if we have a reference here, we are going to write something like const variable name equals instead of just the new resource.
Okay, I think I need to take a step back because it's very hard to follow because I don't have any step of that in my head right now.
That's why we do together.
Yeah, could you show me somehow what is the input of this and what is the desired output? So,
of what exactly?
For example, how does the graph develop over time while things are invoked, kind of? How does that look like, or how does the node map look like in the end? Because you showed me something printing a statement like const whatever equals what ends up in the code, but I suspect that only happens after the node map exists. Does it?
That's a good idea. I'll walk you through it on the high level and then we go into detail. I wanted to explain it thoroughly, but that you're right, that doesn't make too much sense.
I was lost, or I am lost.
Fine. Okay, so basically, this node map here is in a record which has the IDs of each of these elements in it that you would use in Terraform code, and as keys, and as values it has the code generator. And first thing we do here is down here.
For the value for the code generator, is it?
It's a function that generates the code based on a graph.
Okay, so the value of such key is something that is invoked at a very later stage. Where
let me show you where it's invoked, and then we talk about that, okay?
Okay.
So here we add the nodes to the graph. So first of all nodes are created because and like the next stage, we're gonna add the edges.
Could you bring it a bit slower? You just add some nodes, but didn't you? So you have the node map.
Node map has every single ID that's.
Okay, I was saying I thought the graph would equal the node map, kind of. It does not. So it's completely separate. Okay.
It's a different data structure. Like the node map is just like a representation of each node, but without a concept of dependencies. And the graph is that's like the graph object here is it's real graph, a directed graph.
Okay,
and you construct. So
is it if you go through all of them and then you add nodes to the graph?
Let's first a funny thing. We first add all the nodes and then we add the edges.
Okay, I see.
The edges come in later because primarily because this graph implementation here verifies when you add a edge that both ends are there.
Okay.
But because we traverse everything serialized, we don't know, like we can't say that something is already there until we add it. So first we add all the nodes, then we add all the edges. And because of this guarantee, we can do some great assumptions later on that help us a lot. We're sure that the graph is sane in the end.
Okay, now I got that. I thought that the edges had to be in place while adding it already or something.
No, that's why I wanted to jump over to the edges, because first nodes, then we add here the edges to the graph. There's some special cases if you have like dynamic variables, for example. This is why we need to check if the thing we reference is actually in the graph, and otherwise we don't add it. So
what does that do?
Say again.
You just lost me there because I was just thinking and reading the code. So what is the special case there? So there's an if to only add a directed edge if something
there's not
is
one
met.
Already. Like if there's
between those.
If these two have already an edge, because like for example 5 different things, like if you rely in a Docker container on the Docker image tag, on the name, on the SHA or something, you would add like 3 edges, but we don't really need that. We only have 1 at max.
Okay.
And the other thing is there are some temporary variables you can introduce in inside of Terraform configuration. Let me show you. I've got a great bunch of test cases, and I can show you one of the test cases what I mean. I'm a bit sorry that the syntax citing is not really working, but you have, for example, dynamic settings here, which is a dynamic block. and that you can use to loop over the settings, and then
you get setting.value, and that's temporary.
Yeah, you get setting.value, and that's temporary. That's no dependency.
Okay.
Because of like these outliers, I would say we have these special handling here. But in like on a high level, we just add edges everywhere where we detect the reference. We'll take a look at the reference detection.
Yeah, that would be. Okay.
I first want to go on a high level, because if we jump in too deep now, we lose track of the overall.
Okay, could you scroll up again at global edges? Where is it called in there? It wasn't. So in add edges, it was called.
Add edges is the function that actually adds the edge. It gets an ID and like a value.
Yeah.
And the value is, for example, the definition inside of a data attribute or a Docker container or something, or a variable, or that that object that you have in there. That's the value here, and we check that for references.
Okay.
That we're gonna see later.
It would be so nice if that wasn't unknown.
Yeah, it just is unknown. But we're very careful. We don't use any here. We use unknown. We check every case. So, but it's really unknown because it's it's a variadic object or array or something. Can be pretty much anything. I mean, it can't be a string or something. But besides that, it can be a lot of things. So we have to deal with that. Yeah. So that's where we add all the edges that we have. And yeah, once we're done with adding the edges.
Could you stop a bit? So I just need to pass the structure. So that's
the same blob as before. I'm a bit ashamed and unhappy with the structure, but we have to do like yeah.
And it's calling, so they are returning functions, and they are called with the graph and doing things. Oh, so
yeah.
For each global returns a function, and that in turn is invoked with the graph, and it was kind of bound to whatever it needs. Or could you show for each global?
Yeah, for each global is the thing we saw earlier, where you get a graph and the iterators called with the graph. And
okay.
Yeah, I just want to make code reuse a bit here, because it was all the looping over all the different properties that are differently structured was getting out of hand. It's not so nice as an abstraction, but in the end we go over each value of that and call it with the graph just to get the edges added. So if you see at global edges here, I think. Yeah, in the end, we use the global graph here. We don't really pass it in. So probably you could probably also write like that and only get a type error, but no semantic error.
Okay, so that whole construct is just to
Yeah, we just need to somehow loop over everything in this big JSON blob and in the right way for each level. So that's why that's duplicated here, and that's why we use the same things that made more sense in the node aspect than in the
something that just feels a bit off is line 97. So you're calling it out for the outputs, but var for variables is fine because you use var dot whatever in Terraform or in HCL all the time, but I've never seen out dot something. Is that a thing?
No, it's not. We just need a prefix, because if the output has the same name as something else, it could collide.
Okay. Yeah, I see that. It's just like a false friend kind of, because it has like oh, providers or whatever. But okay, yeah.
I can add something here.
No, it's not that important. Just.
Yeah, if you stumble upon that, probably someone else does too.
that comment doesn't have at all, because it's isn't it this the case for all the others as well? So for module and
no, for all the others we have these prefixes here because of the IDs that they have.
So what is the first argument then?
The first argument is the prefix that they have for the ID generation.
Okay, but why is it different without than with
because
module?
You cannot reference out, as far as I know at least. If you do, I might have a bug.
I'm completely lost. No, you can't.
If you use Terraform outputs, you cannot reference them somewhere else. If you use locals or vars or modules, you can reference them. And you need the right ID in order to be able to find all the right IDs inside of different expressions.
I'm unsure about that. I just don't know that. But the code, so like 98 and 99, or now 97 and 98, they look completely the same. But you said they would do something different, but they are also passing the prefix, don't they? But I think we can just leave it as that.
But in the case of out, it's not needed. It's just needed to resolve naming conflicts.
Okay.
And in the case of just some prefix service, it cannot collide with something else. And in the case of module, you could actually use the thing that comes out of that.
But I think it's just fine to have a prefix for all of them, even if it would not be needed. So
yeah, the problem with all the structure here is that there's so many extra cases that's really hard to keep track of everything.
Yeah, I think so. Doesn't seem like a simple thing.
Yeah. So now we have the graph itself. Yeah.
So the graph was built by invoking all the different things kind of and adding edges between them, so that you know which node or which nodes depend on each other in what way, kind of.
Yeah, exactly. So we get all the node IDs that we have in the system. Then we get, and we check each of the values that we have inside of the system, if there's a reference to another node. And if we detect that, then we add an edge between those. So we have now a directed graph that represents the dependencies between each of the elements. And now,
just a short question.
Yeah,
so that was line 100 or something, if you could scroll up. And this line backend expressions, what are they doing?
Oh, that's something different. I move that down, so it's a bit less convoluted, because it kind of breaks the narrative of
okay. We
just need some backends in the end, like GCP backend or something, and that's generating
okay.
that's generating
you just skipped it, and I was wondering what it
I'll move it down so the graph story is a bit more together. Makes sense. It just needs to live somewhere. So now we go into finding the right order for the elements. So we have a nodes to visit array here. And while that's not empty, we are in this while loop, and we go through each node of the graph and check if it's still to visit, and if it's still to visit, we check if it has unresolved dependencies, and if it's no dependencies that are unresolved, then we print it down. And
so let me just process for a second. So 111 nodes to visit includes that one.
That one checks if we have already visited this node.
Okay, so so it's just skipping over everything
that we already
has, and then only those are left that were not visited yet. Then
exactly.
You said something about checking the dependencies. So
so we get for each of the node, we get the neighbors. So where dependencies happen, like in neighbors. So things that oh man, reference and reference C is really hard to distinguish. So in the end, we want to only add something to the array of expressions that we are gonna construct that has nothing that, where nothing is still in the array that depends on
this.
No, other way around.
So in the end, you're trying to make a list of things in the order that you can put them in the code base. So like, okay,
yeah, exactly.
This one has depends on nothing. I can put this first. And now as this one is kind of gone, so it's visited, or it's not in the yet to visit nodes. And then you can kind of skip those. So like 117, so you filter all the nodes that are yet visited, so they are kind of printed out. So it's like the inverse of
exactly
putting them in some kind of list. Okay, and then 119, you check whether there are no unresolved dependencies.
Exactly. If we can, like, this is the check, if we can print that, if it's ready to be put into the list, we filtered out of the list that we have. So we visit it basically. And then we get the code attribute from the graph, which is this function that generates the abstract syntax tree for this particular node in the graph.
So this nodes to visit is okay, you're updating it with filter.
Yeah, I'm updating it exactly.
Okay. I see. I think wouldn't it be faster to just delete that one?
Delete?
So to not create a new array via filter and replace that one. I think that's totally fine.
How do I delete one? I mean, do you mean with like find index and then?
Yeah, just in place instead of. Or is this parallelized somehow? It doesn't appear to be. I think it's just looping synchronously. So
yeah, it does. It's wasteful, but it's like a macro optimization, isn't it?
Yeah, you're totally right. I think we just put it aside. It's just this. I have the same thinking from React, where you kind of are not allowed to change any data because you will trip over your feet then. But no.
Yeah, it's probably not the nicest way. I didn't find like a nicer way to delete one element from a list.
Yeah,
that's strange.
Yeah. And so then you're having const list.
Yeah, then I try to I get from the node in the graph, I get the code attribute, which is this generator function that we have that gets the graph in and returns us the abstract syntax tree. And that abstract syntax tree that we get back is either an array of statements, or it is a single statement. If it's a single one, we wrap it in array to be able to probably push that. Now that I think about it, I could probably use concat or something.
Yeah,
but I'm always super shaky with that stuff.
No, I think that's fine. And then you push the expression, and the expression is kind of some. Okay,
the expressions is here. That's the array of all expressions that we're going to print. And
yeah, I have one question.
Yeah, sure.
So if you have two nodes and they depend on each other, that would run forever, right? If you got
two nodes depend? I mean,
if you have a circular dependency, which is invalid.
That's invalid, yeah. You can't have a circular dependency, can you?
I'm unsure. I would say no.
Yeah, I think that's already invalid in HCL, and that's what I relied on. If it were, we would have an infinite loop.
But is there something checking this? So if someone has invalid HCL code, which can happen, and tries to import it, this will run forever and don't stop at all, because it won't even do an stack trace something thing, because not recursive at all. It's just looping endlessly.
Yeah, that's right. I think I'll check a look and add some comment here. I think the graph library I'm using has some
check for that. Yeah. Oh, that's nice. Just a single line check. Oh, you got some circular dependency in here. Abort.
Yeah, I'm pretty unsure. I have to double check that because it could be that the graph limitation itself already prohibits that. but I'm not 100% confident as we speak right now.
Yeah.
I'll take a look and come back to that.
Should be simple if it has such
be.
functionality. Nice.
Okay,
now you got all the expressions.
I got all the expressions, and I'll just jump over a bit of code because that's just like housekeeping code mostly. And in the end, I put these expressions into a list and call gen on that. I split all these return paths up because I wanted to empower people using this library to use different parts of the generated code for the liking. For example, if you are thinking about a VS Code extension, it's a little helpful if you get all the code that's generated, but you want to have like imports in a separate part in the code base where you paste it, and you want to have the real programming code and paste it in a different part. So that's why that's split up here. And they all run gen here, which runs barbel generate for the program and prettifies it afterwards. So we have a nice, consistent output code.
Nice to let Babel generate it and then put it into Prettier and tell it to use Babel to.
yeah, it's pretty wasteful.
No, I think
no overall, but that's, I mean, for the code sizes that we have, it's totally fine. I couldn't imagine a use case where we have so much HCL that it breaks.
I wouldn't mess around with internals of Prettier to pass it the Babel compatible. No.
Yeah, not worth it.
Okay. Yeah.
That's the base story of what we do.
So in the end, it returns
a string.
So gen returns a string,
and
which then can be saved into a TypeScript file.
Exactly.
Okay.
Yeah, that's also.
So that was the convert to TypeScript. Okay, and then there's some code around that. You already showed me that.
Yeah, for conversion to the other languages, and then we are set.
Is there no support for Go yet in Rosetta?
No, Rosetta has no Go support yet. So we opt out of Go for now, and when Rosetta will add that at some point, and then we can just add a new line here and be done with that.
Yeah.
What do you want to see next? Do you want to see it in action, or do you want us to go over the reference parsing or the code generation? Where should we go next?
I think in action can be the last thing because I only can. We're just looking at the parts that are doing the work, and I can kind of think of what it might do. So take Terraform and make some
that's all it does.
Out of it. But so one thing that flew around in my mind, so we had this node map in line 36 that you were just showing, and then there was a different kind of structure that looked very similar further below, or were you just scrolling fast?
Yeah, that's stuff here. That's for edges. It's just looping over everything.
Okay.
I'm not happy with the with the duplication, but it's a bit different use case in both cases, and in the end, it's fine.
that's fine. The thing that I'm kind of missing there is maybe some comment above this object.values call, which explains. Oh yeah. So you inspect the. Okay, so you're defining some functions there and then using them further down. Okay.
Yeah, I think part of the problem here in our code review is that because of the big font size, you don't see the overall picture that you would normally see. So these belong together here because these are just used here.
Recursively inspect each resource value and reference to any other values. Do you mean by recursively?
So if you have an object, we can look, that's a great point. Let's take a look at that. Why recursive? So both of these call at edges which uses the find used references function here. And that's what we take a look at.
Just a short question. Could you go back?
Always before.
So yeah. So why do you have those different functions? Why they do the same thing and ignore the first two or just the first argument?
Because I didn't want to use bind or some other thing. It's,
okay,
it's just because the iterator functions that we have down here have different, like one needs to add the type and the key. We don't, for the one, we don't need the first two, and for the other one, we don't need only the first one, we only need the second two.
Yeah, okay. And the iterator signature, where's that flying around?
It's different, like in global.
This for each global thing probably. And then that's...
Yeah, that is one iterator here with key, ID, value, and graph. And then
okay.
you have the other one for each provider that has these. And then you have for each namespace, and that has like one more, as you can see here. So it's just different JSON structure in the end that we iterate over.
Then I now have one thing I would like to rename. So for this object.values that we just saw for the edges, the for each, could we change callback to iterator? Or is, no, that's wrong.
To iterator.
Is that wrong?
Here, you mean?
No, that's not the iterator function. I was just wondering because it's just called callback, but the for each global.
Where's the callback? I don't see what you mean.
I was wondering, callback sounds.
I don't see a callback.
No, you return something for each global. Yeah, that one. Oh, sorry, CP callback.
Yeah, I can.
So you no, I think iterator is wrong because iterator takes 4 arguments, and now we're just passing a graph. So that seems off because the iterator actually is that one that you pass.
Yeah, but
could you go in for each global, for example? And
yeah,
just shortly
you pass down iterator, and that's it returns. You don't call the iterator then, but you call a function that invokes the iterator with a graph.
Yeah, but what does for each global return? It returns an array of.
It returns an object which has an ID as a key and a function that takes a graph and returns whatever the iterator returns as a result.
And the iterator returns a function?
No, the iterator returns in one case an abstract syntax tree, in the other case void.
Okay. So
the function we call is this function here.
Oh, no, I think I get that. Okay, so what would you call that function? Callback feels like, oh, it's so arbitrary.
Call it a thunk if you want.
No,
I mean,
that
in the end, it's just a delayed access to graph because we don't have graph in all of the cases in the right point in time. That's the problem we have.
So I don't know if the naming is better, but something like resolve. But I don't know. But
I'm fine.
No,
we can do something like at the edges now.
No.
I mean, that's what it does, right? It adds the edges in this case.
Okay, then let's call it add edges to graph.
Okay.
Better than callback. Yeah, I was just wondering because if something is named callback, it feels like someone is passing it to be invoked later on, which is true, but which is true for almost any function that is passed. So
yeah, no, totally. This is more specific now.
Okay. I think that would have helped me.
Would have helped you, yeah.
Yeah.
Okay. All right. Let's go into finding the references because that's the.
I think I'm just not used to such highly functional programming. I think that's why I'm struggling.
Yeah, I'm sorry. A lot of users you have to endure today because, well, I've used a lot of them. So you ask about the recursion. Why it's recursively, and you're gonna see here. So the item that we have, if it's an array, we need to go over each of the elements to find references used there. If it's an object, we have to go deep into into the object and find all references there.
I'm slower than you are. That's probably because
sorry.
of the second shot today. So the vaccine, not
yeah, sure.
Vaccine. So find use reference takes.
It takes the node IDs that we know of.
Yeah.
And that's crucial because otherwise it's super hard to detect if something is a valid ID or not, like a valid identifier of a reference. And it takes an item, and it has a third argument called references, which
that's
is
to be able to call it recursively.
Exactly. That's
okay.
That's what we're gonna return, and that's what we're gonna fill step by step to get the entire thing in reference. Let's jump to that real quick. Has the start and the end. So reference always has something to do with the string that we get it from. So for that string, it has a start and end place. It has the reference C. It has a reference C by ID. So only, for example, docker image would be the ID, and the full thing would be docker image dot I don't know.
Okay, so the
latest, for example.
So the first is the one that, okay, this is interesting because that depends which block or which resource or data source or whatever is referenced, and the full thing is less interesting now for the graph because we only care about the first level, and further nodes or direct references are just not important for the order.
Yeah, exactly. For the graph, we only need the ID, but we want to use the same function in all the places so we don't have varying implementations. And we want to, for example, if you, we see later that we're gonna go over the values of an item and then transform it into TypeScript code. And for that, you need to be able to find the references from a string, then replace only that part and so on.
Okay.
We have all of that handling of these references and our expressions in general, and how to extract them, how to pass them. All of that is encoded here in the expressions file.
What is start and end number?
That's the in the string. If you count like 1, 2, 3, you can have an index of where it starts and where it ends, and that's the part we want to replace. I can show you in the test.
Of what?
So if you find something like this here, like var input as a string, you want to have the reference be var input. We only use var input, so it's only var input in the full, and it starts in the second character of the after the second character of the string, so here, and it ends the 11th here. And because you could have, let me check for an example. That's a bit, for example, here in this example where you have arithmetics, you have a plus here. We have two references, one for this example bucket and one for this other bucket. And so we need to make sure that when we build the abstract syntax tree, that we have the right places where we inject the actual JavaScript, TypeScript.
Okay, so that is for taking part of the source HCL and reusing it in an override, or?
No, it's not override. It's native programming code. So this one would result. Let's write that just up here. This one should result in something like this. So we make it a Terraform expression, and then we put in this Terraform expression our
okay, because we don't need an override for that, but we would pass some Terraform expression to the TypeScript code, and then in there we reference the JavaScript references kind of twice, so for each of them.
Yeah, exactly.
Okay.
We need to transform what comes into some
Okay, now I get the significance for the start and end. I was just wondering why is that important if we just generate code out of it. But so we also
the code needs to be valid. That's the problem. If it wouldn't be valid code, then it's super easy.
I can see that you must have had quite some fun with the built-in functions there.
Yeah, definitely. And that's like the trouble we have here in general. So there's a lot of special case handling. So you have these for in loops, for example, that have some different handling. I have a lot of tests here around that. So if you use this, no, that's flat. Yeah, I used for too much here. You have these kind of expressions here where you transform something into a different shape. So this transforms a users object into some other like role to name this something thing. I don't know.
What is these 3 dots for?
That's similar to spread in JavaScript.
Oh, okay.
I'm not super familiar with this syntax in general.
Yeah, me neither. Just looked like, okay, it's handling left out code or something, but no. Okay,
no, that's really
HCL.
Everything in here is HCL. It's not not specially.
Did not know that.
Yeah, there are a lot of features actually. I export lots of them while doing this. Every new example is something different. On a high level, we see if it's even a string that's like it's really a reference, because we have to start with the $curly brackets if it's a reference. Then you have this weird thing where you have these double curly bracket references. I'm not really sure why they are used and how they're used, but they are there, and some things are encoded by those. So we have some weird arithmetics here for getting only the inner part, and that gets us this expression string. We have some special handling, as I mentioned here, for the for loop, and then in general we go over each of these possible delimiters. So these are all the things that could end a expression. So for example, like a function call, if we have like a method here, or the dot star operator, or with this funky regex here, if you do property access, so if you do this, for example, that gets caught here. And by these we split these strings, so we have all the different tiny parts that can be one individual reference. And then we check if it should be a reference. So lots of special case handling here for the different things. Like the spread you mentioned, for example. And once that's there, we are somewhat certain that it is a reference, but then we don't know where the reference stops. So we have this data.docker image .name .blah string, and we don't know what part is the ID, what part is the full thing. So we try to find out of the node IDs and scoped IDs. So scoped IDs are, we talked earlier about the dynamic thing that introduces a new variable, and these are added to the scoped IDs array here. So for each of those, we check if we find a match, and if it's one, then also special matchmaking for data here, the third thing. But in general, we just try to get the node ID, and if it's not there, we throw an error, be explicit that we couldn't find the reference used.
Just for special cases, could it happen that if some node ID is a substring of another one, like something has a 2 as a suffix, could that collide there, or is that just separate?
Yeah, that's a great point. And at first I had problems like that, but that's why I went with all the splitting here.
Okay.
Because we don't do like part of or something. We treat the entire thing like it needs to be a complete reference.
Mm-hmm.
Each spot needs to be a complete one, and if it's not, then we kind of ignore it.
Okay.
So we know everything, every spot that comes down here has a corresponding node ID now, and we don't pass it further down if it's a scoped ID, because those don't need to be in our graph, and those don't need to be handled differently. They can just stay inline like they are.
Mm-hmm.
And yeah, then we have some part here that checks if we have a numeric accessor. So, for example, if you have this array access where you do, I want to have the fifth element or fourth element, something.
Yeah.
That's the part here, and wait, and that's needed for us to determine the right full reference.
Mm-hmm.
Because if you have this accessor, the full reference is a bit shorter. Probably have a test case for that, yeah. So if you have a address like this here, we want to stop after this and use a fully qualified name in the output.
Mm-hmm.
So this would go into some string like we would do what the first thing is. So I call it bucket here now, would have a different name, but you get the idea. And then we do dot fully qualified name, and then we do dot and all that stuff behind that.
Okay. Mm-hmm.
So that's how this would translate into it. And so there's some special ending here for the fully qualified name, and we also have to use variables differently because they don't have like an FQN function. They have a dot value function that we need to call.
Okay.
So special case here for variable and fully qualified name, and that's what constructs our reference.
Would it make sense to have a FQN on variables as well for our code base?
Would make this a tiny bit easier at least, but not crucially. I thought about that briefly, but to be honest, it's like these 2 lines here and 5 lines on some other function, and that's it.
Yeah, but I was just wondering whether there would be a reason against it. So from a user point of view, using dot value maybe is counterintuitive. Maybe for a variable, it might even make sense to override to string or something, or value off, so it just can be passed. And
that you can do across language boundary. That's the big problem.
Sorry.
If we were only targeting TypeScript, I'm completely with you, then we can override to value. But in this case, we have JSI in place for different languages. So
I always forget that.
Yeah, that's the tough part.
Okay.
So yeah, we have some variable name making here, also in these expressions. But the most interesting part is here this reference says to us. Here. So this takes the input string, like the entire thing, with plus, with everything in place, and an array of references that are in there. And it constructs either just a normal variable usage, or it constructs
could you show me that a bit slower? So
sure.
Why is that a normal variable usage? What does it do first?
Yeah, sorry. I jumped over that. We for all the refs, we take a look if it's not scoped, like the dynamic thing, why we don't want to have reference. And then we transform the reference to an abstract syntax tree. That's the buff here. So we get the variable name, we can identify out of that. And then for each of the parts after the variable name, we do member expressions. So if the variable is bucket, for example, and you have like, I don't know, location and pricing behind that. We would construct each of these members here in the accessor, that we have the full list, basically, like the full access to the value that we want to represent. If we want to use the fully qualified domain name, we use FQN in the end. If we want to have variable, we use value in the end, and then return this accessor. And that's used on here. So this is the ast we have here. So now this is something like bucket.count or something, or bucket.length, whatever. And that would be returned if it's just one thing that we have. Like if we only find one reference, we can just plainly use it. And if we have more than one, we would create a template string, and yeah, the template string would have all the parts and only replace the parts of the original input string that we don't, that actually are references.
Yeah, I have a question for the line 207. You're checking for this variable use there, like the start and the end. They are kind of enclosed in this. Isn't there also the possibility to have something like var dot whatever in HCL where you don't wrap it inside of?
First of all, no, you have always these. And second of all, this check here is there. So we check here if the start of the thing is after one of these brackets start, and the end of this thing is with the end of the last bracket.
Is that now?
So this both checks if
is that
it could be only one
or HCL. That's
HCL.
Okay.
HCL.
But
these two together check if, like for example, you could have something like I don't know, var.input here. And this one we want to let through.
Yeah.
But you could also have something in here that is.
I know with some function or.
Yeah, exactly. And we check if the reference that we find, if the start point is after this and the end point is before this. That's why we have that part.
May I type? I think in.
I think you can. I revoked the access earlier.
Okay. Then in HCL2 or something, I think there's also the possibility to pass something just as var or local dot name or variable name or something without those enclosing. Would that be rendered as a template string then?
No, the HCL to JSON converter would put these in place.
Because we are in JSON, and
we are in JSON,
that's why we are having this all the time. Okay, now
we are sure that we have them if it's a reference.
Yeah, that's nice. Makes it a bit simpler.
Yeah, definitely.
HCL JSON versus parsing the HCL.
There's already so many special case handlings here. Like
that's true. I just thought about HCL also working without them, but okay.
Yeah, no, good point, definitely. But at least to my belief, that's all.
I think it must. No, it must not. But
I'm pretty sure because also all my test cases use them directly.
Yeah.
I never ever use the other syntax.
Yeah. No, that will work. I hope. Oh, it seems to work at least. Yeah. Okay. And else you build a template.
Yeah, a template string of the parts. And yeah, that's all the handling of our special cases here.
What was the trailing whatever comment there? Trailing quasi?
Yeah, quasi are these
these
template elements.
Oh.
No, it's the quotes. Each element, so template strings are super strange in abstract syntax trees.
Okay.
You have to add the like it's called quasis. I'm not sure why.
Okay.
It's just the template elements, and you have to push them in the right order. You have to have you have to push empty ones even, If you have multi-reference and so on, there's like some assumptions about the number of template elements being as long as one longer than the number of references you have in there and so on. So
okay,
it was quite funny.
Oh,
the last one has to have a true. It's not sure what's going on behind under the hood of Babel here, but
yeah, okay.
it was some fun.
Yeah, I was just wondering.
Yeah,
okay.
I wonder why it's called that way, but I'm not light enough. I think we can jump over the dynamic block stuff because that's just some extra handling here. So next part that could be interesting for us to take a look at is the actual generation. Yeah, here we have some import generation using this cool Babel template function. It's really awesome. It's you write template string and call the result of that template function, and then you get it as an abstract syntax tree, and you could pass in something here as like you pass part of an AST here and do something like, I don't know, $other part or something, and it would include that here as an AST and not as like something else. That's really cool tool. I wasn't able, because of the way our stuff is so dynamic, it's not really usable for the use case normal stuff, but for the imports it was nice to kind of just go ahead and get them in place. So we have this the heart of all of the implementation and is the as expression function. So we basically, for each of the types that we have, like provider, resources, data, and so on, we pass some arguments differently to this as expression function, and this function does the actual AST generation. So there's a lot of
for just whatever was passed. So for data attribute, for variable.
Exactly, it gets like the type, name, and config and whatnot in it, so it knows how to generate it. But it's the same generation in the end for everything. So first it checks if it's a type namespace import, and this is the case if the type has a / or a dot in it. So for example, AWS.NET Gateway. So in this case, we make it a member expression.
For an import. Okay.
Yeah, the import is then done, like for these types, it's done as import star as AWS, and then we use AWS.NET Gateway throughout the code base. So that's how we construct the subject here. In case of this case, we do that. For mod use, we have this weird case where we have 2 times the type. I'll show you that later probably. But that's just how it's currently generated. And then otherwise, we just use the type name itself. So for example, for Terraform variable or Terraform output or something like that, we'll just use this last part, where it's just the identifier. Then we get the provider and providers out of it, of the config.
What's the difference between provider and providers?
I'm not really sure. Some things get provider, something get provider.
Okay.
It was very strange to me.
What was config again?
Config is the entire blob, like the object under a resource, for example.
Okay.
And this is like provider in this case is for aliases.
Aliasing. Okay.
Yeah.
Okay. So that's the alias, and providers is all providers.
Possibly different ways to alias, I think.
Okay. Maybe.
Okay.
Yeah.
If it's provider, you pass in an override expression for provider and otherwise providers. So we don't really care too much what that is in the end. But long story short, we create a new expression with this as the first argument, like for the subject that we created earlier. this as the first argument, the name that we have of this resource as the second argument, and the third one is our TypeScript converted config object.
Yeah.
And that's the key part of the conversion that deals with all the unknowns. I can probably make that unknown now. No, I can't. I was too lazy at one point. Yeah, but in the end, if it's a string, we get the references from the string and turn the references into an AST. This will return just a plain string if it's just a string, and otherwise it return what we had. Like we talked about that earlier. And if it's a Boolean or number, we use the iterators for that. If it's an array, we loop the value to TS function over all of the items in the array. And if it's an object, we mostly do just call value to TS here. There's some special cases again. We have, like, for example, tags. And so it's a funny thing I found today. Tags is a record of string and the value of the tag. But everything else, you have in HCL, you have these resource blocks. And each of the resource blocks is actually an array of an object within an object within an array. So that's why we have to wrap all of those into an array expression.
So, and tags is like a map.
Yeah, if like the value here in this case would be an object, a plain map. But the what we expected to be an array of this exact object.
Yeah.
Because blocks can be passed multiple times in general.
And there's no schema on that to know that tags is like a map and the other thing is a block or something.
No, we don't work with schemas at all in this in this generation. In general here, probably we could do that at some point, but there was a whole different kind of worms to open to if the HCL conforms to some schema. So that's why we have a bit of special case handling here. And we have some special case handling for the dynamics here as well. We just put in whatever the dynamic ref is called. So if you have a dynamic over settings, for example, would put in setting with an empty array because we add overrides later for that. And that's basically the value to TS function. If we go back to the as expression function, you can see the overrides here in place. So we saw that already for the providers. Oh no, wait. Here's the overrides. We're here in the resource, for example, and these can use the for each expressions. They can use counts. They can use dynamic stuff, and that's where we had all the overrides here. So that overrides is just the variable dot at override, and then the string of where in the object we want to override something and the value. So in the resource here, for example, we want to override for each statement, and then we put in the entire value that we had here for each or for the count respectively. And for the dynamic blocks, we have this extract dynamic blocks function that is similar to the extract references thing, but does the same thing for dynamic blocks. And yeah, we loop over all of these blocks and add a separate override expression for each of the dynamic blocks. Let's see if I can show you that. Oh wait, I think I was there already. Yeah, this is the dynamic blocks example here in our tests. We have this dynamic setting here, and in these snapshots. It's a bit hard to read, and a bit is overrated because everything is escaped twice for the snapshot. But here you can see we're having that override for the setting here, and we use all the. This is like a non-template string. It's like an HCL string here for setting value, and we use that in here to generate the similar JSON.
Why does it have this weird name?
Which weird name?
In 277.
This one?
Yeah. I can't see that in 207.1.
Yeah, that's a good catch. You just found a bug.
Oh no.
That's great. One bug less shipped. Where were we? We're here in this one.
Not if it introduces more bugs by building it. Okay.
No, it's super easy to fix. It's not super easy to fix. I'll do that later. But yeah, the problem we have here is in here we pass in the references, but the dynamic block thing is not a reference, but it needs that we it forces us to use the variable name, and that's yeah. I'll add that in
and for each and co, and they already are kind of those.
They are references. Yeah, so they don't have to use that.
Okay.
And we ignore the dynamic blocks inside of the reference parsing because we don't need to extract something there and change something there because there is dynamic blocks. And that's why, like, normally they would be in because they are in there, but in this case, we just skipped over them, so there's no need for it. But there is a need. Yeah, cool. Great that we found the bug. Yeah, in general, that's all the magic that we have for the convert command.
That's some hard work there.
Yeah, and then the other part was super simple in the end. I'll just show you how convert project works. That's the import. I'm really, I just named the convert project here for clarity reasons, because it's just converting the project, not importing it in like an HCL sense. But I think the CLI command is import because it's just easier to read and reason about. But I warn in the import command that we don't import the state, so I hope that gets seen.
Yeah, that makes sense.
So we get a combined HCL string, so all of the HCL we have. We have this helper function here that gets us all the Terraform files in this path passed and read all of them and join them. So that's
are we calling that helper function, or who's calling that? Because
the call of convert project, because I want to make convert project unaware of file system.
Okay. But that one is exported for the user of the API as well.
Yeah, exactly.
Okay.
Exactly. Both are exported to use.
Maybe it makes sense to add some example if you have, or something.
Yeah, sure. We have a README here.
Okay. If it's in there, that's
in the README. You can see the supported way.
Yeah, that's what I was after.
Yeah,
so
cool.
I would try to reinvent the wheel if I got that signature. But if the helper method is in place there already, I think I would have found it. No, perfect.
Cool. If it's not TypeScript, we cannot support it because we do not support it. Not we cannot, but it's a bit hard in other languages.
Yeah, out of scope for now.
Out of scope for now. So in the end, we just call the convert function. Then we prepend we get also the input file, like the main file from you. So the main TS in this case. No, not the file name, the entire file. File content.
So an existing one, or?
An existing one, yeah. So the idea is to do I'm not sure if that's the right way to do it, and we will find out by user feedback, I guess. But the way we do it now is we use Terraform init in a folder, and then we convert the project into the existing one, because I didn't want to duplicate the init functionality, and I wanted to be, people to be able to use their own templates if they have like special handling in there.
But you rely on define resources here and replace that.
Yeah. There's a bit of hacks involved.
I think that's totally fine. The imports, how do they arrive somewhere?
Yeah, we prepend them. We just put all the imports in the start of the file.
Yeah.
And then we replace the define resource here with the actual code. We generate. We have the CDK JSON. We generate the Terraform providers and Terraform modules based on the providers and modules we have, and then we get both as strings out here.
Okay, so convert already passes the providers and modules, so that we can.
Yeah, it's probably not really convert functionality in this case, but
I think that's reasonable to want to retrieve that.
Yeah, we passed through everything already, so we can also just export them. Yeah, and if you
just an idea for this define resources here part, we could we could use our TypeScript template, duplicate that one, and that has some scaffolding code that's run already when you do init. And we could add some user query feedback, so that's async there, and ask the user, do you want to import something? And then we could kind of retrieve the source directory. So we could have a TypeScript from HCL, and then the user would be queried for the original, so for the HCL code directory. And then we could just invoke our convert project and with the other methods flying around. So it's possible. I'm a bit unsure about dependencies.
That's a good idea for people to discover this feature as well. I mean, it's init is in every guide, and if init just asks at some point to import from someplace. Yeah,
it could, but I think let's do that in the future.
Yeah,
first
you can
find
also
out if the code is valid.
Yeah, I think that's before we promote this hard, we can just first see.
Yeah, it should work.
Yeah, I imported every like there's some example repository which has like 6 examples for the Google provider to use, and I could import all of them. But I found
they synthesized.
They synthesized correctly.
Okay.
Yeah. So it's working to some extent. There's probably some edge case that I didn't cover properly that we're going to run into, but
yeah,
I hope I'm sure we're going to send this around internally and find a lot of people with HCL code bases we can run against.
Yeah, that's a nice thing to throw against the code base.
Yeah, definitely. And the import command is really simple. As you probably already guessed, we have this init run here. We get the main TS.
What does init run do?
It runs init.
So Terraform init.
Oh no, it runs our CDKTF init. I wrapped that in helper.
Oh, okay.
It invokes CDKTF init for you.
I didn't know that import did that. Oh, okay.
No, I mean, it does now. I mean, I wrote it. So I wrote it to do this.
Have you added two? Oh, you added convert and import. I was just mixing the two.
No, sorry.
Okay.
Convert is for just small snippets, and import is for an entire project. That's the idea.
Then we don't need to put that into the init itself now if it already does such a thing.
I mean, we could though. We could think about it for people to discover it more easily, because you wouldn't search for import necessarily if you're a new user, and might expose you to functionality that you know. But maybe we can just add it to the thing in the end. But we could also we can make this better, I think, in the long run. But first things first. We get the main. Yeah, we read the main file. We read the CDK JSON, pass both down with the language, and then we convert the project, so invoke the function we saw earlier. In the end, we also run a npm run get for you, so you have everything in place.
Do you have some test case that breaks if someone or we modify the TypeScript template and the CDK tf.json is located somewhere else, which won't happen, probably,
Nope.
or the add resources here would be renamed or something?
No,
some,
no, I
just
don't.
Some smoke test would be nice. That calls this command with.
I have one that converts a project, but I create the files needed by hand here.
Mm-hmm.
But that might be a good idea to refactor this one to use the init command.
No, I think it's reason. I'm unsure, because you would have to have this code, not this twice, but you would need this, and then you would need to manage this manually. So that's the downside of keeping it that way. But if they were separate, you would see with some test case that you broke either or, and not by breaking the import, you accidentally break this convert test as well. So I think I don't know how simple that is in the end, but
probably we can do something. We have already here some exec sync functionality. No, wait. I have a wraparound exec sync here, exec, of course, every time. That takes a command in like the working directory, and we could probably run CDK tf init with enough stuff in it.
Yeah.
And then
I think I would do this for
that's probably easier,
in a separate test case. Run init, run synth, and see if there were any errors. That would be totally fine with me, because if the resources break and the string replace does not work anymore, it would not error and it would not do anything. It would just be empty. Maybe some snapshot or something. But
yeah, I'll do one.
That maybe
I added it to do.
I didn't know that. Well, I forgot.
Yeah, I learned that the other day. It's really handy.
Nice. Oh wow! I don't know if I could have built that, what you just built. Not just in 3 weeks. It
was a lot of fun. A lot of small individual challenges. Yeah, and I really hope everything works as expected, or we find at least the bugs early on. It's could be really helpful for people.
It looks like a code base that can take not refactor, but working out bugs. So it doesn't look like, oh, this is reaching around from everywhere and it looks very brittle or something. So I think it looks kind of stable. So
it shook out somewhat into some form, and I'm happy with some parts, not happy with other parts, but I think they all look good enough for now. And yeah, I think getting this out and getting more feedback is more important than polishing now. Yeah, when we have the feedback, probably some of the structure will change either way, because some bugs will uncover that something was wrong, or some assumptions were wrong that were basis for this. So yeah, I assume that in the end, in half a year, I'm going to do a big refactor of that.
Yeah, nice.
Or someone will do that.
Yeah, someone at least.
Yeah, cool. Do you have any more questions about what we have? I think we touched on every single file that I have. Yeah.
Not currently. Still need to process. So after this 1.5 hours, my brain is, I think, exploding.
It's quite a lot.
So yeah.
Cool.
No, but
yeah, then thank you for your time.
Yeah.
Thanks for posing all the questions and finding all the bugs.
Thanks for building this. It's so useful.
Yeah,
I want to try this on Terraform project.
Yeah,
just
please do.
Against them.
Get all the HDL files in front of it and see what it does. And yeah.
Nice.
Also, fun fact: all the I have like a metric ton of the snapshot tests, and they're both super useful because you find like these unintended errors that unintended changes that you make. but they're also super useless at some places because, for example, this dynamic block thing, you just don't see that in a div. You just look over it.
Why don't you see it?
Because if you look into a div of these things, they're just super big, and you have like 6 files changed or something. Or if you create a new one, you like if this is created, then you always only see the lines that are changed. And if you don't purposely go in after creation and change it to the thing it should be, then you are, and it's super hard to catch that, because if you look at the snapshot file, it's just super big in a blob of unhighlighted nonsense, sorta. So that's super hard to understand and to parse in a way.
Yeah, I think I once updated a snapshot that we took of the AWS provider or something. So that was like, okay, most of it looks right, but it
looks sane, but
yeah. Oh yeah.
It would be a cool test to add in at some point to run TypeScript over the generated stuff.
Yeah. some kind of, does this compile?
Yeah. Yeah, cool.
Nice. Yeah, thanks
for
showing. Should we stop the recording then?
Yeah, let's do it.
Go for it.
I can't find the
Okay, I will.
If you have the button.